Hello, dear aspirants. This is Dr. Sourav Sir Classes. Our contact number is 9836793076. Again, I am repeating our contact number, which is 9836793076. And our email ID is sourceclasses@gmail.com. So, if you have any mathematical query, statistical query, or anything, so please feel free to contact on this number. That means you can call on this number or you can WhatsApp also. Rather, you can drop an email to our email ID, which is sourceclasses@gmail.com. So then our team can arrange it our clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Like if you are preparing for CUET PG Statistics, so please feel free to contact us. Then you can enjoy all the services of Dr. Sourav Sir's classes, like our sessions and our weekly mock test, etc. So please feel free to contact. Okay. So now we are going to solve a problem which is appeared in the CUET PG Statistics, and the question is telling us that if xn, sorry, that will be an, that's a typo in the question. So it will be if an be a real sequence such that the limit n tends to infinity, an plus 1 by an is equals to L. That's appears to be the comparison. Okay. Or like the ratio test. Okay. So where our mod L is less than 1, okay, the absolute value of L is less than 1, then limit n tends to infinity, an is equals to what? So there are four options here, which are 0, 1, half, and infinity. So this is also a very easy question. So we are given a real sequence an. Let me, yeah. So now my screen is ready. So we are given a real sequence an such that a limit n tends to infinity, a n plus 1 upon a n is equals to L, where our L mod of L is less than equals to 1, and we are tasked with determining the limit of this sequence as n tends to infinity. That means we are going to find this thing, limit n tends to infinity, a n equals to. So now we are going to analyze the given limit. So the limit n tends to infinity, a n plus 1 upon a n is equals to L, tells us about the ratio of consecutive terms of the sequence. So specifically we can say that if our, let me change the color. Okay. So if our mod of L is less than 1, then the sequence a n converges to 0. And if our mod of L is equals to 1, then what will happen? Then the sequence may converge to a finite limit, diverge, or oscillate, or depending on the specific behavior of the sequence. Okay. So now case 1, where our mod of L is less than 1. So if mod of L is less than 1, then for large n, the ratio a n plus 1 upon a n is approximately L, and mod of L is less than 1. This implies that the terms of the sequence an are shrinking in magnitude. Formally, we can show that so now we are going to think about our case 2, which is mod of L is equals to 1. So if our mod of L is equals to 1, the behavior of an depends on the specific sequence. For example, if our L is equals to 1, then that will be what? If our L is equals to 1, then our every uh, term by term ratio will be 1. So all the terms are same. So then that will be a constant sequence. So, or rather we can say that if our L is equals to 1, the sequence an may converge to a finite limit an equals to 1 for all n, or diverge an equals to n, or oscillate when our an is equals to minus 1 to the power n. So if our L is equals to minus 1, then only this case appears. Okay, so thus when our mod of L is equals to 1, the limit n tends to infinity an cannot be determined uniquely without additional information about the sequence is given. Okay, so now the conclusion. So for our mod of L is less than 1, our conclusion is that the limit n tends to infinity an is equals to 0, and for our mod L is equals to 1, the limit n tends to infinity an may or may not exist, and its value depends on the specific sequence. So our mod of L less than 1, our limit will be 0, and mod of L is equals to 1, then cannot be determined uniquely without additional information. So the correct answer of this question will be our option A, which is 0. Okay. So again, I am telling that if you have any other mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or you can WhatsApp also. Rather, you can drop an email to our email ID. Then you can join as a student to our institute and you can enjoy all the services of Dr. Sourav Sir's classes. Okay. Thank you guys. Hope you understood. Thank you.